Welcome to week 8. Welcome after the break. Today we are discussing operating system security, and this is module 8 of this semester. Like we have done in the previous modules, the key terminology in today's lecture is to understand the term baseline or baselining. We can define baseline as the process of establishing a system's security state. It describes the capabilities of a software system. We are specifically talking about operating system. And once we analyze what security features we need to have in our system, that resulting product or resulting analysis is known as a security baseline of that system. Baseline allows us to run the system in a safe and secure environment. Once we determine the security requirements of a system, any similar system can be configured with the same baseline to achieve the same level of security and protection. In an organization where you have got many computers, you just have to decide once that what will be your security requirements. Once you analyze those security requirements, analyze the risks associated, keeping in view your company's, your organization's business and the associated threats. Once you analyze all these things and you say that we need to avoid these softwares, these applications in our system, that is known as your security baseline. Once you analyze that, you will implement the same security baseline across all the systems that are running in the production environment in your organization. It is essential to develop these baselines separately for servers, for workstation, and personal computers, laptops. Since we are talking about operating system, we need to understand what is an operating system. We all are using operating systems. Few of you are using Mac. Few of you are using Linux. Majority of you must be using Windows operating system. What is an operating system? It is a system software that provides an interface between the user and the computer hardware. Your computer hardware is a dead entity. You cannot use those components. You cannot use those ICs. You cannot use that CPU, that RAM without a system software, without an operating system. So that operating system is an interface between you and the hardware that executes, that runs those dead devices, those dead components. Operating system is responsible for management, coordination, and sharing of computing resources, such as I have listed a few here: hard disk, CPU, RAM, your network interface cards. If you're running multiple applications, like we all do on our systems, we have, like at this moment I'm running Panopto, I'm running PowerPoint, I've opened Blackboard, I've opened Word document, your tutorial activity, which you have to do today. So all these 4 or 5 utilities, these applications, they are being shared by the same CPU, same RAM. So who is maintaining all this? The operating system, the interface between me and this hardware device. Operating system can be broadly divided into 3 layers: physical hardware layer, operating system kernel, and user application and utilities. The components in an operating system that communicate or that enable that dead devices to run falls at the category of physical hardware. Operating system kernel is the main entity, main component in an operating system that coordinates between the physical hardware and the user applications that we are running on our desktop. And the layer that is associated with user applications and utilities that enable those third-party applications to be run on that operating system. All these 3 layers need some hardening measures and some baselining requirements to ensure that we have got a secure system which is safe from malicious entities. Australian Signal Directorate, ASD, maintains a list of top 35 mitigation strategies And as per ASD, they say that among these 35 top 35 mitigation strategies, if we implement the top 4, we will prevent at least 85% of the cyber intrusions. And that's why they've made it mandatory for all the Australian government agencies to at least implement the top 4 mitigation strategies. What are these top 4 mitigation strategies? Whitelist approved applications, patch third-party applications, patch operating system vulnerabilities and use the latest versions, restrict administrative privileges. Among these 4, 3 are directly associated with operating system security. Apart from patch third-party applications, the other 3 are associated directly with your operating system security. Other than Australian Signal Directorate's top 35 mitigation strategies, 20 critical controls, also known as CIS controls, are famous security strategy that is implemented by CIS Institute in the United States. So it is parallel to Australian's top 35 mitigation strategies. So you can always refer to 20 CIS controls or 35 mitigation strategies. The poster that I've added in today's reading compares the 35 mitigation strategies with the CIS controls. The question is why we are concerned with the operating system security. We are concerned because we have got a greater dependence on IT infrastructure. We have got clients, we have got server systems that are running all our critical business. And these servers and clients hold critical data, critical information. They run our critical applications. And now it has become a necessary tool for the success of any organization. So when we are so much dependent on the servers and the clients and this digital information, we need to ensure that the operating system, which is the interface between us and the hardware, is secure enough so that we don't end up compromising our business attributes. Presence of any vulnerability in any operating system that we are using would largely compromise our business functions and will have direct effect on our business turnover. So that's why it is very essential to build and develop and deploy a system that requires well-planned approach, well-thought-out approach, well-written approach, well-set security baseline that we can use before making our system available in a production environment. NIST special publication 800-123 states following measures that we should be performing to ensure that our operating system is secure. First of this step is assess the risks and plan the system deployment. We need to assess the risks that are associated to our business, similar to what we discussed in Module 2. Once we assess those risks, we then plan the deployment of our system. We need to secure our operating system and the key applications that we will run on that operating system in our business environment. We need to ensure that our critical data is secured, the contents are secured. We need to ensure that appropriate network protection mechanisms are used to defeat network-bound threats, and we need to ensure that appropriate processes are used to maintain security, such as patch management. If we do not implement patch management at regular intervals, we will not be in a position to say that our operating system is secure and our environment is secure from vulnerability, from cyber criminals or cyber intrusions. One of the wrong concepts in the industry is that people say that we just install the operating system with default configurations and then make that system available in the production environment, and then later on we will inspect the security requirements, and then we will configure all those security issues, or we will patch all the security loopholes that are there in the system, which is a very, very wrong concept. Imagine if you install the operating system on default configurations without implementing any security control, and you start using your operating system, your personal operating system that is running on your laptop without any security configuration. You have compromised your data, your critical information, to the cyber criminals. And if you think that you will implement security after making that system, connecting that system to the internet, you have a very wrong concept about security. Because by the time you will implement any security control, your data might have been compromised. A malicious user might have installed a backdoor in your computer. So that's why we need to configure, we need to install all the security mechanisms before we make that system live, before we make that system available in the production environment. What we need to look at is the overall security requirement of the business for which we are developing the security baseline, which applications are required to run on that system, which data we need to use and we have to store, what is the criticality of that information that we are processing, who will be the users on the system, what will be their privileges, and what will be the access control mechanism on that system. How users will be authenticated, whether we need single-factor authentication, two-factor authentication, or multi-factor authentication, whether we need to implement biometrics or we need to implement tokens. So these all needs to be assessed before we make our system available to the end users. And above all, we need to assess whether we need any additional security software, such as antivirus software, software-based firewalls, or software-based intrusion detection systems, or IDSs. Our foremost priority should be, when we talk about operating system, is to secure the base operating system, secure the default installations of our operating system. We just cannot afford to leave these default configurations, because they are the operating system, the default configurations are there for the ease of installation, but they are not secure. If you trust that whatever you've installed is secure, will save you from the cyber intrusions, then it is a very wrong concept. Some of the very basic steps by NIST about operating system securities are install and then patch the operating system with the latest security updates, remove all unnecessary services, applications, and protocols. If you leave them open, it's a paradise for the hackers. If I talk about Linux operating system, that you have, like, you may have installed Ubuntu on the virtual machine that we are using. If you run what services are running, you will see there will be some services which you do not need at all, and those services will be vulnerable because they have not been patched. So why to run those services? Why can't we just close those services, close those ports on which those services are running, because we just don't need them? So it is a very important and critical step that once you install your operating system, you install the patches, your next step should be to look at which services are running on that operating system and whether we need those services or we just need to simply close or remove those services from the operating system. We need to configure the users, we need to set their passwords, we need to set up the groups if we are running in a domain environment, and we need to set the permissions for those users. One of the initial steps when we are installing the operating system is that once we are doing the installation process, system should not be exposed during setup phase and must be installed or configured on a protected or isolated network. So good organizations who have got a very robust information security model, when they first install the operating system, they do not install it in a live environment in their production network. They have got a separate isolated network which is there by default only for the sole reason of installing the base operating system and then configuring the security or implementing those security baselines. Without doing these activities, they cannot connect that net system onto their production network. So in an organization, when you will go in any organization, if you are the information security expert there, what should be the policy in that organization? The policy is, as soon as the new system comes in, you need to install the operating system, but where you need to install it? In an isolated network, not on the live or the main network of that organization. You need to secure the BIOS. You need to set the boot priority. If you set your boot priority onto CD-ROM or USB, that is an open check for the intruder or for an insider attackers to compromise that system when it will be up on the LAN or your production network. We need to install the critical security patches, and we need to enable automatic download and install security patches, which is the ASD's recommendation. I want to emphasize on this last bullet because there are two schools of thoughts. By default, ASD recommends that we should enable automatic downloads and install security patches, but there's another school of thought which says that we should not be doing it, because by doing it we may compromise our critical applications, because we may end up facing an issue where our applications may not be running because of that particular update. It might be the case that a third-party application that is running on the operating system might not work correctly because of the latest updates. So in those cases, if you are running a critical application in your network and you think that installing a security patch with this configuration, enabling automatic download and installing those patches, may restrict your normal routine, what you need to do is to download those security patches in an isolated network, see the effect of that application, which is critical to your business, and as soon as you see that our application is running smoothly, immediately install those security patches on your live computers or live network. Do not install unwanted software. There will be some applications which will be installed by default by your operating system during the base installation. You need to see that whether those applications are necessary for your organization, and if they are not, you need to uninstall or remove those unwanted applications. People may say that we can install these applications at a later stage, but there is a risk because uninstalled scripts may fail to completely remove all components of a package. And if one package is not removed, that might be a target for an intruder to compromise and get into your system. You need to remove or disable accounts, change default passwords, and enforce policy for password security. I've used the word whitelisting. We need to understand what is the difference between whitelisting and blacklisting. Applications that can be controlled by the operating system when they are started comes under the definition of whitelisting and blacklisting. Blacklisting means applications that should not be allowed to run by the operating system. So for example, if we see that we do not need to have Notepad, it's just an hypothetical case. We see that Notepad is a vulnerable application which is installed by default by the Windows operating system. We feel that this is not required by our users. We should be removing this unwanted application from that operating system. This should come under our security baseline. Whitelisting is the exact opposite. All those applications that you think are essential for your business, are required by your end users, should be allowed by the operating system. All these applications fall under the category of whitelisted applications. So we have discussed about the basics of operating system security. We are focusing on Windows security. We will not be focusing on Linux security architecture. Why we are focusing on Windows? Because it is the world's most popular operating system. It is used by the wider community. Since it is used by the wider community, it has got some interesting security related advantages. But what we are concerned about is that it has got some serious challenges as well. What is the main challenge? The main challenge is that since it is being used by the wider community, by millions of users around the globe, security vulnerabilities, there are more security issues with the Windows, because non-technical users are more inclined towards using Windows operating system than Mac or Linux operating system. Talking specifically about the Windows security architecture, the fundamental security components of Windows architecture consist of these items: the security reference monitor that works at the kernel level, the local security authority or LSA, security accounts manager, SAM, Active Directory, AD, authentication packages, WinLogon, and NetLogon. These are the essential fundamental security components of Windows operating system. We'll discuss the SRM, LSA, SAM, and AD in next few slides. But before that, we need to understand this diagram. This is somewhat an hypothetical, I would say, diagram of Windows security architecture, where we have got a logon process where we enter our username and password or any other multi-factor authentication if we have got smart tokens or biometrics. As soon as we perform that login process, we then go towards LSA, which is your local security authority. And that local security authority has got your security policy database and your audit logs. We'll understand more about these terminologies in the next few slides. And then we have got security reference monitor, SRM, which works at the kernel level. Then we have got security accounts manager, SAM, which maintains your user IDs and passwords. And then it looks into your SAM database, where it compares your hash values of your password with the hash values already stored in that database. And that compares, if the hash matches, then you are allowed to enter into the system. So what is the security reference monitor? As I've explained, it works at the kernel level, which is the second layer of the operating system. It performs access checks: who is allowed to enter into the system, who is not allowed. It generates the audit log entries. It does not maintain. LSA is the entity that maintains those audit entries. It generates the audit log entries that are maintained by LSA. And it manipulates the user rights, which are also known as privileges. So it is like this barrier that you can see in the diagram. So that barrier allows who is allowed to enter into the system at the kernel level, what services are allowed, which function a user can perform, and which a user cannot perform. All this is done by the security reference monitor. Then we have got local security authority, which can be recognized by lsas.exe if you go into your task manager in Windows. It issues security tokens to accounts as they log onto the system. It is responsible for enforcing local security policies. And what are those policies? Such as password policy, auditing policy, and privilege settings. All these activities are being managed by local security authority in Windows operating system. SAM, Security Accounts Manager, it's a database that stores your local accounts information and their relevant or associated security information. When a user logs on, as I've explained in the diagram earlier in the slide, the SAM process takes the login information and performs a lookup operation in the SAM database, and then after matching the hash values, it allows the user to enter into the system. If SAM does not recognize the credentials, if the credentials are not valid, if SAM comes to know that the password that you have entered is not correct, it will not allow you to enter into the system. Active Directory AD, when we are working on a network environment, like when you go to your labs, when you log on to your system, you're not actually logging on to your local, you're not being authenticated by your local system, not by the SAM or the LSA, you're being authenticated by the Active Directory, by the domain controller. So when you enter your username and password, that is securely transferred from that computer to the server room where the Active Directory is. Your credentials are compared by that Active Directory, and if your credentials are okay, then you are allowed to use that system. Security identifiers is an important concept in Windows operating system. When a user is created or a group is created in Windows operating system, they are assigned a unique identifier, which are known as security identifiers or SIDs. Every user and individual account will have a different or unique security identifier. For example, if there is a user, if I create a user with my name Imran, if I remove that, Windows will assign a security identifier in the database. If I remove that user and if I create another user with the same name Imran, that will have a different security identifier. Two names will never have same identifier. It's like a concept of primary key. If you can understand the concept of databases, it's a primary key. Every user that is created on the system, whether that user has been removed, will have a different unique security identifier or SID. In a domain system or in a local system, we can create different groups for different users, and Windows have got a many-to-many relationship when we talk about users and group. A group can have many users. A user may be in many groups. When I log into a computer, I'm in a different group. My group is staff group. I have got some privileges which you do not have. When you log on, you're using your credentials. You are part of a student group. So when you log on into a computer, you have got some privileges and you have got some restrictions which restrict you to not to perform a certain action. You cannot install any software on a lab computer, whereas you might have a different group who is allowed to install software because that group is allowed to perform those actions on that very computer that entity is using. What is the advantage of making groups? Can anyone tell me? Yes. Imagine ECU has got approximately 30,000 students, So instead of creating the security policies for every single student, they have created one single group, which is a student group, and they have assigned the security policies to that single group. So all 30,000 users are made part of that group whenever their user ID is created. A simple Windows login process works like this. The first step is an administrator creates a user account. Once that user account is created, that is assigned a security identifier or SID. That SID typically looks like this number. We are not concerned what these numbers are, but that security identifier looks like this, and this is a unique security identifier. Once user is created and that user is assigned a security identifier, user initiates a security authentication sequence or SAS, where a user types in a username and password or any other authentication mechanism, security tokens or biometrics. Once user enters the credentials, the LSA runs an authentication package, which is lsas.exe. User is then authenticated by locally or by a domain controller. If you are authenticating Using a local account, you will be authenticated by the local SAM database. If you are logging on onto your computer using your domain credentials, your data will be sent to the Active Directory and you will be authenticated by the domain controller. At the end, SAM will return an SID to LSA, and based on that SID, LSA will maintain your audit logs, what actions you have performed during the course of the time when you were logged onto that computer. LSA creates access tokens, and those access tokens contain user's individual SID, security identifier, the group SID, and the local system rights. The token that is generated by the LSA is used by the SRM, which works at the kernel level, to ensure which objects, which actions are allowed to be performed by that user or by that SID, and which privileges are not allowed to be performed by the user that has been logged onto that computer. Windows has got some special accounts and groups. We all know administrator or admin. We know root in Linux. So administrator is the most powerful user. Administrator is allowed to perform any action that he or she wants to perform. Then we have got some user accounts, which are the restricted accounts, where you can only use the operating system. You cannot perform any installation. You cannot remove any software. You cannot play around with the system files. We have got some guest accounts. Normally, the concept of guest account is dying as we are moving more into Windows 10 and the future updates that we are getting. And then we have got the concept of groups in Windows, where we create some groups and we assign multiple users onto that group for the ease of management and maintenance. So that was all about Windows security, a brief overview. The last topic of today's lecture is virtualization security. Why I have added this virtualization in today's lecture or with the operating system? Because we are going towards virtualization more and more. Why we are going towards virtualization? The reason is we have got servers which are very highly capable, that can perform many actions, and using one operating system on that server, generally or normally, you are not using that server up to its maximum potential. So if you use virtualization, you can run multiple operating systems in your production environment, and you can truly utilize the potential of that high-end server. This is one of the reasons. I believe you all know what is virtualization, because we have been working on virtualization software like VMware or VirtualBox in our lab activities in this semester. The more formal definition of virtualization is available on the slide, but if you find that this definition is difficult, then you can write in your own words. It's a technology that provides an abstraction of the computing resources used by some software, which then runs in a simulated environment, which is known as virtual machine. So the Kali Linux that we are running on our VMware or VirtualBox software is our virtual machine, and virtualization software that we are using is VMware or VirtualBox. Okay? So you need to understand what is a virtual machine. Your Kali Linux is your virtual machine, your Ubuntu is your virtual machine, and the software on which you are running your virtual machine is your virtualization software, which in our case is VMware or VirtualBox. This was one of the questions in your tutorial activity earlier in the semester, the difference between type 1 and type 2 hypervisor. A type 1 hypervisor is a software layer loaded directly onto a physical server. It is also known as native virtualization. It directly controls the physical resources of the host. If you look at this diagram, it has been taken from your textbook William Stelling's. type 1 hypervisor or native virtualization, you've got a hardware, you then install a hypervisor on that hardware, directly on that hardware, and then on that hypervisor, which is your virtualization software, you then install your guest operating system. You can run multiple operating systems on a virtualization software or hypervisor. Our next category of hypervisor is type 2 hypervisor, which we all are using in this semester. It exploits the resources and functions of a host operating system and runs as a software module on top of the operating system. It is also known as hosted virtualization. You need to have a base operating system on your hardware. On top of that base operating system, you install your virtualization software, and on top of that virtualization software, you install your guest operating system. If you look at the second picture, which is type 2 hypervisor, you've got a hardware. On top of that hardware, you install host operating system. For example, Windows operating system, if I specifically talk about the environment that we have got in our lab. So we have got our hardware on our desktop machines. On top of that hardware, we have got Windows 10 operating system. And then we have got VMware software, which is our hypervisor or virtualization software. On top of that virtualization software, VMware, we have installed Kali Linux, Ubuntu, or any other flavor of Windows 7, 10, or XP or Vista. So do you understand the difference between what is the difference between type 1 and type 2 hypervisor? In type 1 hypervisor, there is no base operating system. That's what is called native virtualization. And in type 2 hypervisor, we have got a base operating system which is running on top of hardware, and then we install our virtualization software on that base operating system. Native virtualization is typically seen in servers as they improve execution efficiency of the hardware, and we can use the hardware to its maximum potential. Native virtualization is considered more secure as they've got fewer additional layers than the alternative hosted approach. Just imagine that if you are running a type 2 hypervisor, you need to ensure the security of your base operating system, and then you need to ensure the security of your virtualization software, and then you need to ensure the security of your guest operating systems, and on top of that you need to ensure the security of your third-party applications. Whereas in type 1 hypervisor, you need to ensure the security of the hypervisor and then the guest operating system. So that's why they are considered more secure than type 2 hypervisors. And then there's a third type of virtualization, which is known as container virtualization. It's a relatively new concept. Has anyone used this container virtualization with software? Okay, have you used Docker? Have you heard of Docker? I have used Docker. So one of the example that, what have you coded? Proxmox. The other example I can give you is Docker. These two are the container virtualization applications. And what is a container virtualized application? It looks like this diagram. You've got a hardware. On top of that hardware, you have got host operating system, which is similar to type 2 hypervisor. So instead of installing a virtualization software, and on top of that virtualization software, a guest operating system, we remove those two steps. We install a container, Docker or Proxmox, and then we install our application that we want to test or run. It does not mean that we cannot install an operating system on a container. We can run an operating system in a containerized environment, but we can also run some application that we want to test or we want to run on top of the container. So on top of container is not the right word, inside the container. It is, the container is sharing the resources of the of the host operating system. Some of the security considerations. This is in addition to what we have discussed earlier in today's lecture. In addition to the operating system security considerations, security baselining, and all other concepts that we have discussed, we need to consider these three critical issues when we are using virtualization in our environment. One is guest operating system isolation, which means that ensuring that programs executing or the applications that are running within the guest operating system only access and reuse the resources allocated to them. They should not be covertly or hiddenly using the resources that are not intended for those applications that are running on guest operating system. The hypervisor or the virtualization software should be able to monitor the guest operating system. So we need to ensure ensure the security of the virtualization software. And once we have got the virtualized environment, secure virtualized environment, we can then be in a position to say that yes, our guest operating system and all those applications that are running on top of that guest operating system are running in a secure environment. So we need to segregate the resources, we need to segregate the access rights and the privileges. Imagine if an application running on a guest operating system starts using a resource which is only allowed by the host operating system, then you might end up in a problem. Any compromise on that application that is running on top of guest operating system may lead to a compromise of your host operating system. So we've discussed so much about operating system, but what we need to understand is that operating system is a complex piece of software. It consists of millions of lines of codes, and there's it's a common phenomena, which is agreed by by everyone, that the more lines of codes you have in a program, the more vulnerabilities you will have. So an operating system is a complex piece of software. It consists of millions of lines of codes, and you will have some bugs, you will have some flaws. That's why you regularly get security patches, security updates from the vendors of those operating systems. That's why we keep on saying that patch management is the essential step in a security of operating system, or a security of a network, or a security of an organization in a broader category. So every operating system will have design flaws, will have implementation errors, and these errors, these flaws leads to vulnerabilities. Whether we have implemented sound software engineering practices, we can reduce the occurrence of these flaws and the occurrence of these implementation errors, but we cannot say that we do not have any implementation error, we do not have any design flaw. Another issue with the operating system security is whenever we get a new operating system, the vendor often say that this operating system is backward compatible. So what is the issue with backward compatibility? The issue is that if you are running two different operating systems, one new operating system which is more secure than the previous operating system, and the previous operating system is also running on your network, the issue is any vulnerability that exists in the previous operating system can be exploited by a cyber intruder or by any malicious actor, and that compromise may lead to a compromise on your network or on your database or on your applications or data that you are using. So backward compatibility is a requirement for the vendors to give, but as soon as you decide that we have to switch to this operating system, we need to ensure that all our applications are updated in a manner that they run on the new operating system. Still to date, you might see some of the ATM machines that are running on which operating system? XP. So imagine an ATM machine using Windows XP software. XP has been outdated by Microsoft so many years ago, and people are still using, the industry is still using that ATM machine. They are still using Windows XP. What is the reason? The reason is that the application, the ATM, the software that is running is compatible to Windows XP. They have not taken this pain of upgrading their application to be able to run on Windows 10, or some other reason. Might be the case that their hardware is not compatible with Windows 10 or any other flavor of Windows which was released after Windows XP. This is quite a serious concern. Yes. Whenever they introduce a new operating system, normally they introduce by comparing the previous version. Like when Windows Vista came in, they said that Windows XP is compatible. When Windows XP came in, they said that Windows 98 is compatible with Windows XP. Always the previous one, but there are few cases like Windows, when Microsoft launched Windows 8, that didn't work. So when they launched Windows 8, they said that Windows 8 is compatible with Windows 7. But then when Windows 8 didn't work, when they launched Windows 10, they said that Windows 10 is compatible with Windows 7. So giving a compatibility is the requirement for that vendor. But this is in your hand, that when you have decided that I want to use Windows 10 in my environment, in my organization, you need to ensure that all your applications must comply with the Windows 10 requirements, and then you upgrade all those applications that cannot be run on Windows 10 to be able to run on Windows 10, and you just remove the previous versions. The other thing that you need to consider is that till what extent, till what time frame that vendor is giving the security update for that operating system that they have declared, the previous operating system that they will declare obsolete. After how much duration they will declare that operating system as obsolete, and they will no longer be giving any security patches. So majority of you in your first assessment have chose the WannaCry as one of your malware. So what was the problem with WannaCry? People who did not updated their operating system with the patches that was released by Microsoft, all those systems were compromised. And look at UK National Health Services, UK NHS, which is the most critical service. Health is the most critical service. They did not update, they did not patch patch their operating systems, and that one SMB component was compromised using that WannaCry software, WannaCry malicious software. The question is, which is the most operating system? There is no straight answer, to be very honest. You might have heard that people saying that Linux is the most secure operating system, or Mac is the most secure operating system. This is a wrong answer. By default, there is no secure operating system. Windows can be more secure than Mac or Linux if your security baseline is good, if your risk assessment is good, if your configuration is good, and vice versa. So if someone asks you that which is the most secure operating system, do not just blindly answer Mac is the most secure operating system or Linux is the most secure operating system. The answer is that it depends on the security configurations, security baseline that you have developed for that organization, or even to that extent for your own laptop or your own operating system, desktop computer. So if a question comes in the exam, for example, that is Windows a secure operating system, yes or no? So don't just answer that yes, it is a secure operating system, or no, it is not a secure operating system. Your answer should be just generate some arguments. Say that there cannot be a straight answer, it depends on the security baselines, your risk assessment, the organization's working or the business that you are into, and the way you have configured your operating system. Okay. So this brings us to today's lecture. If you look at today's tutorial activity, there are a few questions that I've added which you can answer at a later time. Part 2 is directly relevant to your second assignment. I've given you enough for your second assessment. You can use these resources to develop your assignment. And part 3 is about Linux. I've been telling you throughout this semester that Linux, understanding and learning Linux is essential if you want to survive in this security industry. There's one book I have referred, I've given the link on the additional contents. You can use that book and try to understand these basic concepts of Linux, file system, tree in Linux, what is absolute path and what is a relative path in Linux. And the more important thing which is directly relevant to today's lecture is the last bullet, permissions, which is chapter 9. Do not just read the entire chapter, just follow the commands that are available in that chapter and run those commands on your Kali Linux or your Ubuntu virtual machine and try to understand how permissions work in Linux and how they are associated with the security of that operating system. The additional contents are available here. You have got Australian government Essential 8 maturity model that includes the top 4 and the other 4 as well. I have given you the entire information security manual for the Australian government. You can get some hints for your second assessment from here. This is the ASD top 35. It's a very good and precise document. If you can read this document, that will be a very good addition to your understanding. It says which are essential. It explains the top 4 and what each of that category means. I've added this CIS control, which is equivalent to ASD's top 35 mitigation strategies. You can see they have broadly categorized these 20 into basic CIS controls, which are first 6. Then they've got foundation CIS controls, and then they've got organizational CIS controls. So you can get few hints from the first 2 categories, basic CIS controls and foundational CIS controls. I've added a poster. Please keep this poster handy for all other units that you will be studying in the following semesters, because you will be needing them. First, it explains the CIS top 20 controls, and then in the second page, it shows you these are the 20 CIS controls, and then they are mapped with the NIST framework, and then they are mapped with the Australian top 35, this column. Okay? So this is a very handy poster, which I would suggest to keep it handy for rest of this course that you are doing, because you will be required to refer to this summarized version of mapping or CIS controls mapped with all other mitigation strategies that are being implemented by different security agencies and government agencies. Like you can see, it talks about GC headquarters, which is the UK's intelligence agency, their mitigation strategies. It talks about NIST Cyber Essentials, NIST Cyber Framework, and it talks about Department of Homeland Security as well, and other frameworks that are available in the industry. This is the Linux command line book, and I want you to go through chapter 9 in today's tutorial activity. And these are the NIST publications. These two might not be relevant for your assessment, but keep them handy. They are directly relevant to virtualization. But this one should be good for your second assessment. This talks about general server security guidelines, which you can use in your second assessment. That's it. I'll see you in the tutorial activity. If you've got any questions regarding your assessment, I'm available here for next 10-15 minutes. You can come and ask your questions. Thank you.